Hello everybody, my name is Satya. Welcome to this vlog. So in the last vlog, I discussed about security in internet basics. So I talked about what is the importance of public certificate and how these file types represent which file types represent public certificate. I repeat again, these are file types ending with .cer, .crt and .cert. So these are authenticated by trusted public key infrastructure parties. If these are not trusted chain of certificates, then your operating system browser will flag it off, saying that it's not an legal website or authenticated website. So you are entering a very non-private zone, right? So that is a problem scenario because your data might be spoofed, and a man in the middle can understand what you are trying to do with those web pages, right? So especially when you are doing transactions for payment and all those things using credit card, always make sure that the certificate negotiation is authenticated, right? Now let's delve deeper. How the TLS, that is transport layer security, is established. In my previous classes, I have dealt about this topic, that domain name system DNS protocol is used to get the IP address from a website URL, right? Uniform resource locator. So that is translated into IP address using DNS, domain name server queries. Once you know the IP address, you send a request to that server, and that's handshake is called as TCP handshake, so that the packets are reliably sent. That is transmission control protocol, and it uses handshake mechanism, which is SYN, SYNAC, and finally ACK. I've already dwelled or discussed about these concepts in my previous classes. Please check all the videos. One of the videos will be talking about these protocols also. Now let us dwell into the topic of this vlog, which is called as TLS. The transport layer security starts with client sending hello packet and server responding to that hello packet. You need to understand these are the steps, protocol messages that TLS uses. Client hello, server hello, they exchange the random numbers, client random number, server exchanges server random number. So like that, these things happen, which I'll discuss separately. But what is important is a private key. The private key usually is supplied by .p12 or .pem files. These private keys are unique to client and unique to server. These are never exchanged on the TLS session in the internet, right? So client will not share its private key with the server, server will not share its private key with the client. It's only the public certificate that is sent, right? And that has to be authenticated, and that should be a authenticated chained set of certificates. Now, what does this private A mean? Private key. So what client does is, it creates a shared key from this private key. How it creates is, it's a lot of algorithms are used. I will explain in a simple way. They use a random number which was earlier shared between client and server, a private key which is unique to the client itself when client is making a shared key, and a large prime number which is also random, a really large prime number. Client prepares a shared key. In the similar way, server uses its random number, its private key, and a large prime number which is also random. It generates its shared key. Now, this shared key is sent from server to client, and client sends its shared key from client to server. Then again, once the shared keys are used, these shared keys are again mathematical algorithms are applied, because client has its client private key, server shared its shared key, that will be a mathematical algorithm will be applied and a new key will be generated, right? And server in the same way as a shared key plus its own private key, that will be mathematical algorithms will be applied and a separate key is generated, right? Now finally, these keys will be used to encrypt the data that is sent between client and server. Now, final output of these mathematical algorithms is in such a way that client will have a unique key and server will have a unique key, which are both same, because the shared key and the private keys were applied with mathematical algorithms to come to a encryption key that is unique to this session only. I repeat, initially during TLS handshake, clients and server allow random numbers are exchanged, right? Then client will have its own private key, never exchange over the internet, and server will have its own private key, never exchange over internet. Client generates a shared key by applying mathematical algorithms on the private key plus random number plus a large random prime number. Server also applies mathematical algorithms to compute a shared key which is obtained by applying mathematical algorithms on private key, random number, and a large prime number which is also very random. So once these shared keys are generated, they're exchanged between client to server, server to client, right? So once these shared keys are shared between client and server, server to client, a new encryption key is obtained, which is obtained by applying mathematical algorithms on shared key plus the server shared key which is sent to client will be again applied with mathematical algorithms using this shared key plus the private key on the client. Server also does shared key plus its private key to obtain a unique encryption key that will be used to encrypt the data between client and server. So this is how the encryption works. Now, what mathematical algorithms, if possible, I never worked on these mathematical algorithms, but I will try to study them and try to explain them how these mathematical algorithms work, right? So I don't want to commit because these are really difficult algorithms, need to be understood, but I will try my best. But what I wanted to share as part of this vlog is the basics of the encryption, right? What is public certificate, which are provided by the website, if those public certificate is authenticated by a public key infrastructure authenticators, then only your session will be encrypted, otherwise your session will be private. No, private in the sense it will be public and it will be visible to all. It's not private, I should say, right? So to summarize, I want to tell you that DNS is used to resolve the IP address of the web server. TCP is used, transmission control protocol is used to establish a reliable connection between client and server. It is SYN, SYNAC and ACK. That also has been explained in the previous vlogs. Third is the TLS handshake, which is discussed in depth as part of, or in a brief way as part of this particular vlog. So client prepares its own encryption key, server prepares its own encryption key, right? And these are the same encryption keys uniquely obtained after applying mathematical algorithms. These are never shared over the internet. So all the data exchange between client and web server, which is secure, is encrypted using these encryption keys, right? So that's how we can trust the websites when we are doing some financial transactions, right? So these keys are never shared. So it's probably impossible to encrypt these packets, or I should say decrypt these packets by the man in the middle attacker. Okay, so this is what I wanted to discuss. Thank you for your time. Bye.